Okay, this video will be a continuation of lesson 9.49.5, trigonometric ratios. So in the last video, we introduced you to the trig ratios, how to set up a trigonometric equation with one of these ratios, and we talked about how to solve that to identify different parts of the triangle. So there were three different ratios: tangent, cosine, sine. And we chose the correct trig function based on the parts of the triangle we were comparing to create our equation. So let's just quickly rehash what that looked like. Here's my triangle here, and it gave me one of the acute angles, 72 degrees. So I set up an equation that said, well, I know the adjacent side, I want to find the hypotenuse. The trigonometric function that uses a and h was cosine. So I would set this up cosine 72, because that's the reference angle, is equal to the adjacent over the hypotenuse, and we solved. Now, what we're going to look at today is called the inverse trigonometric function. Well, what do we do if we know both sides, but we want to find the angle? And you sort of have to undo the cosine or perform the inverse to actually solve for the angle. So let's just look at what that looks like as far as the notation. I'm going to just do a few examples and kind of identify the way that we write inverse and so on and so forth. So this says find the measure of each unknown angle for the triangles given, and I'm going to look specifically at number 7 here from your notes. And you can start with any of the angles that you want to find. If it's asking me to find both of them, then I'm going to find both of them anyway. So if we go ahead and we just start with, let's say, angle A, and I want to find the measure of angle A. Which angle here would create a side length of 7 over here? And in what we'll do is we'll create an equation. Now notice, just like we chose a reference angle before, if my reference angle is A, then this over here, 7 inches, would be the opposite leg from that angle. And the one next to it, 4 inches, would be the adjacent leg, right? We don't know anything about the hypotenuse. We could find it. We don't really need it, though, to find this angle. So then we go ahead and set up that trigonometric equations like we're used to. So the ones that uses the leg and the leg, I'm going to write up here just to remind us, are SOHCAHTOA. So sine is related to opposite over hypotenuse. Cosine is the adjacent leg over the hypotenuse. And the tangent is the opposite leg over adjacent leg. So the one that uses the two legs is the tangent. So I'm going to write this as the tangent of A is equal to opposite, which is 7 inches, over adjacent, which is 4 inches. Now again, we talked about trig ratios involve three things: an angle and then two sides. And as long as you know two of them, you can find the other one. So notice we know both legs on this one, so we want to find the angle that would create that ratio of legs. And the way you sort of undo, right, a tangent, or you do the opposite operation, just like when you want to undo multiplication, you divide by a value. You take the inverse. So what this would look like algebraically if I wrote it out every single time, which I know you guys will want to just shortcut and not do that. But we would write tangent inverse, and this is what it looks like. I know that looks like tangent to the -1 power. That's not what that means, and it doesn't behave that way. It just means the inverse tangent. I'm undoing the tangent. And if I take the inverse tangent, so to speak, of this side of the equation, then I have to do the same thing to the other side of the equation. So just like when we're solving, we do the same thing to both sides of the equation. When you do that, a tangent inverse essentially undoes or cancels that tangent. That's the only way to bring that angle value away from the tangent, which means on the other side we have tangent inverse of 7/4. So essentially when you plug this into your calculator, you're saying if the tangent is this ratio, what angle, right, would give me that tangent? So in your calculator, to find the inverse functions, you just push the second button first and then put in your ratio. So I'm going to go to the calculator app that I've been using. Again, you're going to push the second button, or that blue button. When you push that button, that takes you to those inverse tangents. So I'm going to push tangent there, and then remember it was 7/4. And once you put that fraction in there and you push enter, it should give you that degree measure. Now let's check real quick that we're in degree mode. So I'm going to push mode, which is right by your second button. Notice down there, mine's on the third line. I'm in degree mode, so I'm good. So that should represent about 60.255 degrees. And if you look at this, it doesn't really tell us where to round, so we'll just round to 1 decimal place. So we're going to end up with A is equal to 60.3 degrees. Okay, now there's 2 ways to find B. One, you could use the inverse tangent again, but use B as your reference angle. Or remember that in a triangle, all the angles have to add up to 180. So oftentimes, once I find one of the angles, the other angle is just going to be 90, because 90 degrees is already used up with the right angle. You're going to take the leftover 90 degrees and you're going to subtract out whatever you get for A. So I would do like 90 minus the 60.3, and that would leave me with the value of B, which would be 29.7 degrees. Again, you can use the inverse tangent twice, or you can subtract it from 90. So let's do this again on number 8. Again, if we look at number 8, choosing a reference angle, it doesn't matter which one we start with, I'm going to choose B. If I choose B, this over here, 23 is the opposite leg, the one next to it is the adjacent leg. So once again, I have O and I have A, which in this case is the tangent function once again. So I'm going to set up my equation, the tangent of B is equal to 23 over 31. Now you will see over and over again, the more you use these, you'll realize, okay, well, if I want to find B, I take the inverse tangent of the fraction. Notice the fraction doesn't change, the SOHCAHTOA doesn't change. We just use the inverse function. So this is inverse tangent of 23 over 31. So I come here, I do second tangent of 23 divided by 31. And that gives me a degree measure of about 36.6 if I round. So B would be 36.6 degrees. Now again, I can subtract that from 90 degrees and end up with the A value, or again, I just want to show you this, I could just use the trig function again, but if A is my reference now, notice that 31 is the opposite leg and 23 is the adjacent leg to this angle. So when I set up my little like tangent of A is actually going to be 31 on top because it's opposite over adjacent. So when I find my A value, I'm doing the inverse tangent of just the reciprocal of what I did before because we're using the other reference angle. So if I come here, when I do my inverse tangent, I don't know why it keeps going back to that screen. Inverse tangent of 31 over 23, and that gives me 53.4 degrees. And again, one way to kind of check my answers, I just make sure if I were to add the two angles that I found together, they have to add to 90 degrees. They're complementary angles. So 36.6, 53.4, that would give me the 90 degrees that I'm looking for. Okay, let's look at another example, maybe one that doesn't use tangent. So I'm actually going to flip over to the next page. If you'll turn over in your guided notes to the next page. It says use the inverse trig ratios to solve for the angles, so we can use any of the above. Number 15 asks us just to calculate the measure of angle C. So this is angle C over here. Again, if that's my reference angle, it looks like we're given the hypotenuse and we're given the adjacent leg. So I look at SOHCAHTOA. Oh, I'm going to write it one more time. We're hopefully getting really good at writing this. If I look at the one that uses H and A, looks like that would be cosine. So in this one, I'm going to use cosine of C is equal to adjacent over hypotenuse. And again, if I'm solving for C, in order to pull C out, I take the inverse cosine of the other side. So it works just the same with all the trig functions. You're just choosing different, or you're given different parts of the triangle. So I go to my calculator and I do the inverse cosine, so second cosine, and I go ahead and put in 24 over 30. That gives me about 36.9 degrees. On a lot of your assignments, if you'll just kind of look at what it asks you to round to, if it doesn't ask you, go ahead and do the tenths place. If it does ask you, then make sure you've read through those instructions. Okay, let's do one application. And this application down here is just a very simple and basic one. This says if a wheelchair access ramp has to have an angle of elevation of 4.8 degrees and has to rise 18 inches above the ground level to meet the porch, how long must the ramp be? So again, one of the hardest parts about application problems is just understanding what it's asking for. So it says a wheelchair access ramp. Well, if a wheelchair is going to go up a ramp, right, it probably is going uphill just a little bit. And it can only be going up 4.8 degrees. So here's the ground, right? Obviously, you don't want that wheelchair falling back down. So we're only going to go up 4.8 degrees. That's that angle right there. I just tried to squish it in there. And it has to rise 18 inches above the ground level to meet the porch. So there's a porch up here, right? Once they go up the ramp, and it says that it's going to be 18 inches. And we're asked how long the ramp needs to be. So up here, right, this is the piece of wood or the cement you're laying or whatever this ramp is going to be. That's going to be the length. So if you look at this, this is just a trig function. Or we can use a trig function to solve for this. This one we're actually given the angle. We're finding a side length. So again, we're kind of going back to, well, we know what the opposite leg of that angle is, and we want to find the hypotenuse. So again, O and H, if we look at our SOHCAHTOA, O and H relates to the sine function. So we choose sine, and we set up our trig equation. So sine of 4.8 is equal to opposite 18 over x. Again, if we're solving for this, we're getting x out of the bottom. So that means that we're going to divide to solve by the sine of 48. Now again, we're not using the inverse function on this one, right? Because we are solving for a side length. So 18 divided by sine of 48. We put that in our calculator. And it looks like we end up with about, oh, that is not 48. I apologize, that's 4.8. This is why I need you guys in the classroom to fix my errors. Okay, it's getting worse. Sine of 4.8. There we go. Whew, ramp's got to be a little longer than that. Okay, 215.11. So you could answer this, right? How long must it be? Well, it's got to be at least 215.1 feet, maybe a little bit longer if you're actually going to reach that porch. But that's kind of what we're looking at when we're using that to solve. Again, just identify kind of what you're looking for. If you're being asked to find an angle, then we need to go ahead and apply that inverse trigonometric function. If you're just looking for a side length, then we use our trig functions related to that specific angle there.